Welcome everyone to the Wildfire Cluster meeting. It's August 13th, 2026. We have a fantastic speaker today that I'm very excited for, specifically developing work on spatial knowledge graphs and infrastructure to coordinate disaster management broadly. Um, uh, Everyone, welcome Nathan McEachen. And I should note that this is also a preview of an upcoming uh, uh, workshop at the November Phosphor G event, where Nathan's going to be doing a 3-hour workshop on similar material, which I'm very excited for as well. Um, so, uh, and my name is Tim Bailey with the ESIP Wildfire Cluster, and welcome, Nathan.
Hello, everyone. Yeah, thanks for having me. Happy to share about our work, especially because it was funded within the context of disaster and response and resilience for flooding scenarios. So I've tried to adapt some of the themes to wildfire. So a little disclaimer, because I'm not an expert on wildfire, some of my examples may be a little off just because I lack some of the domain expertise. But one of the things that encouraged me to share with you guys is I do want to hear from you at the end. And actually feel free to ask questions during the presentation to learn from you how these principles could really be applied to wildfire. So ideally, as we develop approaches for bringing geospatial awareness into large language models while establishing integrity, provenance, and trust, that those approaches should be domain agnostic. So if you've developed in one particular domain, you can unintentionally create something that is only applicable to a limited set of domains versus more broadly applicable. So I'm really looking forward to hearing the feedback from you guys on this work. So some background about myself. I have a master's degree in computer science. I started TerraFrame a number of years ago. We got started actually in the disease space. So writing open source geospatial solutions for disease intervention efforts like malaria, dengue fever, and visceral leishmaniasis. So in that process, we had to develop an open source stack that could integrate geospatial data across a number of different domains. But in this context, geospatial is a spreadsheet with a column with a village name that doesn't necessarily have a standardized spelling using the Latin character set. So like a village name. And so how do we integrate data across these different sources by location when there aren't standardized IDs? And so we created a geo-ontological framework to help infer semantic identity using human in the loop and so forth. And so that's how the company got started. And make a long story short, we now do work for U.S. Department of Interior and USDA, more specifically through U.S. Forest Service. But that work with Forest Service has more to do with UAV sensor processing and management. So, okay, so what is GeoAI? That's something that we're all discovering. I mean, uh, best practices are being discovered now through collaboration, through transparency, and I'm actually very involved in the Open Geospatial Consortium, and this is a topic that always comes up: is what do we need to standardize? Where people are using GeoAI, and so for some people, GeoAI is they think of it as something that can help your geoscientists do their work better, faster, cheaper, and that's very important. Where our work is more focused on is how do we leverage AI to make the data, the wealth of geoinformatics data that is available, especially across different sectors. How do we make that available in a format to where it can be integrated and consumed by large language models? And so imagine a world where people can ask questions about geospatial, consumers of the data, that would typically involve a big upfront data integration effort. So in this example, what populated areas would be impacted by a wildfire? Well, USDA and the Forest Service, they don't have all of that data. You know, the population data comes from census. And wouldn't it be great if I could get answers like this ad hoc on demand without having to undergo some extensive data integration effort because the data is across the different federal agencies are published in a format that makes them automatically interoperable and easily consumable by large language models. So our work has been funded primarily through the U.S. Army Corps of Engineers Civil Works Division. And also we've participated in a number of research projects with the Open Geospatial Consortium, including the more recent AI DGGS research project. So in both, so with our current customer and then also in those research projects, we wanted to explore approaches where people could ask ad hoc and on-demand type questions in a disaster scenario, where you really don't have time to integrate the data or find the data, integrate it, and then do your analysis before you can actually answer the question, because the situation on the ground is moving very, very fast. And also, it's really important to understand not just the immediately impacted area, but what's the cumulative effect or downstream impact. So in the case of flooding, you could have a health facility that's inundated, yet you have people who are living on dry land that need access to medical care, that have urgent medical needs. Let's say someone might need kidney dialysis or something like that. And so you can imagine the chaos of a disaster response. People are focusing, and rightfully so, their efforts and their attention on that immediately impacted area. And they just don't have the bandwidth to really understand what the true domino effect is. And so when it comes to the full network effect from a disaster response, you guys know this better than I do. This is true for flood inundation and especially for wildfire, is transportation routes get disrupted, right? So not only how do we take the existing data that we have that is really important for decision support during a disaster response effort, but how do we have a process where we can receive new and up-to-date information and have that automatically be reflected in the answers we're getting from a large language model. So to be able to ask ad hoc, on demand, your questions, and then have some assurance in the provenance and trust of the answer that you're getting. Because I think you guys could imagine that if you don't have that, then what's the point of the solution? If the solution is telling you where you need to focus your efforts and you don't really have trust, I mean, you could be wasting valuable time just trying to figure out how trustworthy the answer is from the model. And so for fiscal year 27, Army Corps is going to extend this outside of disaster response, that kind of context, and use it for site selection. And so before they actually dig ditches and pour concrete, they want to make sure that they can vet the answer given them to the model as far as where would be the best sites to get the best bang for the buck for building infrastructure to prevent flooding. So there is this natural human desire to believe that, well, the AI is just going to figure this all out. AI can just ingest all these different data sets on its own. It's going to figure it all out. It's really, really wicked smart, and it's going to give us the answer. Well, I'm not going to say it can't do that or ultimately won't do that at some point. But what this research paper highlights is that large language models have a hard-coded limit when it comes to the amount of complexity they can actually handle. Now, that limit implicitly increases as these models become more and more capable, but the reality is there is a hard-coded limit. And so if you really want to have large language models do more, then it's important to reduce the cognitive burden on the model itself. And so one of the ways you can do that is by making your data more interoperable from the get-go. So without that, if you expect the model to automatically integrate data, it's going to be spending its precious cycles focusing on that problem and won't necessarily have capacity left to answer the question. So you're seeing this being addressed a lot with multi-agentic architecture that with each agent being configured to address certain types of problems and then having the model chain them together to perform more complex tasks. So the more we can reduce complexity on the model, the more we can have trust in the answer, and then also leverage it to do ultimately more. And so what I'll be talking about here is something called the spatial knowledge graph. I'll also be touching on DGGS, don't think I touched that. Okay. Um, so in a spatial knowledge graph is a way of modeling information that is feature centric rather than feature type centric. So you create explicit relationships that represent the results of your geoinformatics and your analytics. So I'll get more into that into a second. But the takeaway here is if you can present your data in a way that's much more interoperable upfront, much more explicit, then the model, when it is translating your natural language question into something that's actionable or something that's queryable, you're giving it a semantic structure that is already implicitly language based. So research is also showing that the amount of text that models can digest, we're going to be reaching that limit here pretty soon. And so one of the ways that we can supplement a model that does not have access to local geospatial information, especially information that's up to date. So, as you can imagine, in a fire response, I doubt anyone here goes to ChatGPT and asks, "What's the current situation on the ground?" It just doesn't know. And so, retrieval augmented generation, or RAG, is a very common process for supplementing the model. So it's a way of providing additional information that is in a certain type of structure, typically using a vector database, that allows the model, and through configuring the agent, the model can know, okay, I am aware of some sources that I can look to that may answer this question. And so in a vector database, it's really good for associating very similar terms with each other. And so if you want to provide additional context in the form of text, if you have some additional text documents that are relevant to certain domains, this is great for that. The model can then defer and look at the text that's been ingested into the vector database. However, they are horrible structures for representing networks of features and how they're related to each other. So if you want to understand if this dam were to breach, what farming parcels downstream 100 miles away that grow soybeans would be impacted. So that kind of networked understanding of the features, it actually can't do that. It can only make associations 2 to 3 degrees of separation. But in the case of disaster response and also site selection, it's important to understand degrees of separation, 10, 20, 100 degrees, to really understand that downstream or cumulative impact of a disaster event. So, like I said, vector databases are great when it comes to bringing additional text into the context of a large language model. But here are 2 additional structures that are incredibly complementary. One is spatial knowledge graphs, which I mentioned, and I'll be getting into. I'll be diving to that here shortly. So again, in a spatial knowledge graph, think of it as something that is feature centric, not feature type centric. So each location, each feature has its own representation, and then it's related to other features via these edges that have a semantic label. DGGS, discrete global grid systems, is a way of representing aggregate and statistical data by breaking down data into these cells. Some people call them cells, depending on where you are on the planet. Other people call them zones. In OGC, they're calling them zones. And so if you aggregate your data by these common points of reference, and there are several different reference systems. Some are hexagons, some are triangles, and there are several different layers. So if you, what's called quantizing, aggregating data from a particular area into a cell at the lowest cell level, the specification allows you to aggregate upward. And so the advantage of that approach is you can bring data together from multiple different sources that have all been quantized to the same discrete global grid system reference. And so just a little background, I want to give some thanks to the OGC because our work with the DGS has been primarily with the OGC, but we have one US agency who's interested, so I hope to have some good news to announce there. in the next month or two. But so these are the participants, and so of that project. And so the demo I'm going to showcase came from that. It was work is funded by USGS, Natural Resources Canada. And so the idea is how can we use DGGS in this disaster response context and large language models? And we as a participant, we're unique in that we combine both. We combined our work with spatial knowledge graphs and DGGS. So just again, to kind of go over DGGS for those who aren't familiar with it. For some reason, this is kind of more adopted in Europe, but it is now an official OGC standard. And so, like I said, basically there are these different reference systems that have different shapes, and it can be raster data, it can be vector data, but whatever the indicator is, you quantize by associating what the equivalent value of that indicator should be within the space of that zone for that particular zone level. And so here are some examples of the different. There's actually about a dozen, and I'm sure people here have heard of H3. That is also technically DGGS, but is not an OGC standard. My understanding is H3 is really optimized for like transportation use cases, but when it comes to things like hydrology, there are other DGRs that are better based on their shape. In fact, I reviewed a research paper for the upcoming, and I accepted it for the upcoming Phosphor G conference in Hiroshima, Japan, talking about how one triangle-based DGRS was really good for modeling water flow. And so I'm not an expert on why each of these reference systems were developed, but I know that this ICEA 7, here we see ICEA 3, but ICEA 7 is a really, here we go, is a real popular one. So again, so if data are published using DGGRS, then you get implicit interoperability from the start. So it really is a paradigm that shifts interoperability to the publication side. And so as long as multiple data sets are using the same reference system and quantized data to that system, then data can be integrated on demand, ad hoc, by these different zones at these different zone levels. So that's incredibly, incredibly useful. And so, disclaimer, this is a bit of AI slop here. I had ChatGPT generate. So you might look at this and go, well, that's not entirely correct. But the idea was to give you guys an idea of how this could work in Wildfire. So up above, we have data that has been quantized from rasters. But you can also have vector data as well. So the idea is that if you have a fuel moisture data that came from rasters and you quantize it, and then you have vector data like population or property value, then these zones would then line up, and then it would be very easy to then expose those as RAGs to your GeoAI solution, where you allow people to ask questions and then kind of get the answers. So where do we have the most areas that are at risk of burning, and also the highest property value, and also vulnerable population groups, something like that. So, all right. So when it comes to spatial knowledge graphs, there currently is no standard for publishing spatial knowledge graphs in a way that is interoperable from the start. And so for those of you who are not familiar with spatial knowledge graphs, you may have heard of something called RDF or triples. So a spatial knowledge graph is a simple, it's composed of these simple triples: subject, predicate, object. This area is in a burn risk from this forest. That's a semantic edge that represents that the spatial association between those different features. So the reason why this is important is if you look at your database, your traditional database tables, like we have here on the left, and you were to ask the waterway segment table, which administrative boundaries do you flow through? I mean, that information does exist. And so if you want to answer that question, what typically happens is People will then get the administrative boundaries table, we'll get the waterway segments table, and they'll do their geometry arithmetic, and they'll spit out an answer, and they'll create a map, including a report, whatever it is. But that integration effort is not something that is reusable by the broader community typically. So when we do our integrations, they're point-to-point integrations for us. We use them, and in some times, even within our own organization, those integrations aren't necessarily findable, or they're integrations for data that occurred from a different period of validity. It's no longer valid, and so the boundaries have changed, and so we have to do it all over again because you know administrative boundaries have split and merged since we last did that integration. So what our objective is by working with the OGC, this is not an official effort yet. That's what we're working on. I've got some promising signs that it will be, is what kind of standard can we develop to allow organizations to publish their spatial knowledge graphs in a way that's interoperable. And what that means is that each of these features are semantically identifiable across the entire ecosystem. So if someone publishes a spatial knowledge graph that pertains to transportation, another one does hydrology, another one has done something involving population, that someone else can then, a third party could then integrate and snap those graphs together like Legos. And so just to clarify, maybe I didn't describe this point very well. So these edges that we're talking about here, right? It's how do we represent the results of our, geoinformatics, capture that in the semantic edge. Is it fire risk? Is it downstream from, and so forth? That's the bridge between the model and the knowledge stored in the graph. So you can configure, and this is actually captured in the workshop that I did last year at FOSS4G North America, and the one I'm doing in the upcoming FOSS4G North America, where we're extending spatial knowledge graphs with DGGS. But that's the bridge where you can configure the agent to then translate that natural language question into a graph query, in this case, a geosparkle query. And so, one of the advantages of that, the key advantage, is that the model itself, as you'll see in the demo, it's not coming up with the information on its own. It's getting the data from the graph, or in the case of DGGS, it's getting it from the DGGS collection. Hallucinations tend to manifest themselves as invalid graph queries, in which case it just errors out. And something we haven't seen yet, but we can't rule it out, it is possible that the model could generate a graph query that doesn't ask the question you intended it to ask. So it could give you a different answer, or an answer to a different question. But the key point here is both DGGS and with spatial knowledge graphs, you have traceability into that answer. You can look into the graph and see where did that answer come from? Now, it could be that the data in the graph is wrong. That's possible, but at least you can understand how the model got that answer. So before you start actually building infrastructure, committing assets to something, you can do that. You can do that audit workflow. And then we're trying to take it a step further. This is why what we want to do this in full transparency with the OGC is we want to associate provenance to this. So it's not just sufficient to understand the data that's in the graph, but where did it come from? And so there needs to be provenance metadata that points to, let's say, a DCAT file, for instance. Who's the source? What's the period of validity? What version of this? So I understand where the values came from. So, okay. So this is back to the point made earlier about how it's very challenging for AI to integrate all the data on its own and to do so accurately. Part of the reason why it's not always deterministic, it's not always possible. And so I have permission to share this slide from the US Army Corps. So here on the left, each row represents the same dam from a different silo. So there are no consistent IDs. The labels, I mean, as a human, I can read this and go, okay, these seem to be the same thing. I think so. Although Big Ditch Lake, that doesn't seem to make sense. How is that a dam? It turns out it actually is. But also the point here is when it comes to the geometries, right? The geometries aren't necessarily deterministic because some may be polygons, some may be lines, some might be points. And so that's why it's important to have a mechanism to where you publish a graph and you're referring to features, that there's a way to deterministically identify the semantic identity of those features. So where these two come together, DGGS and spatial knowledge graphs, is that you can ask, well, so for things like at flood risk, again, aggregate and statistical data lend themselves very well to be represented as DGGS collections. And so I can imagine in this field, vegetation moisture. I'm sure that people in wildfire have come up with their own indicators to represent fire risk. There could be a lot of geoinformatics behind that. But areas that that have been identified at risk of fire, again, like we said, population lend itself very well. And then so once you've identified those areas, then spatial knowledge graphs can help you understand what that downstream or cumulative impact is. What are the things outside of the area of interest that may be impacted, like I said before, access to medical care or disruption in transportation. And so then how we do this is we do this through agent configuration. So like I said, my first workshop last year was just about configuring the agent for knowledge graphs. And this time we're going to add DGDS and how you can orchestrate between the two. So how you can configure an agent to understand if I'm asking a question, is that a question that I need to answer by generating an API call to a published DGGS collection, or do I need to generate a graph query? And so the idea is that to the user who's using the solution, they don't have to think in terms of DGGS or spatial knowledge graphs necessarily. That the agent will figure out what it should query, and then also figure out how these things overlap. So this is what we're this vision setting here. This is what we're working on with Army Corps of Engineers. So the idea is that we're creating a standardized approach for them to publish their own spatial knowledge graphs in a way that's interoperable, so they can publish data across these different systems, and then they can integrate the data across these systems themselves. And so one of the reasons why we're motivated to go down this direction is that, so back to when I shared the origin story of my company TerraFrame, how we worked in public health, our work was funded to work in lower resource settings. So there's just a lot of public impact, positive impact that could be obtained if we focus on solutions that work in lower resource settings. And so one way to create these types of solutions where you can just ask a question from a prompt and just get an answer and have trust in it is there are a lot of commercial vendors who are trying to do this, of course, right? Where you give them all your data and then you're licensing their solution, but they have control over that solution. The goal with this approach is we're giving the individual organizations the ability to have sovereignty over their data. They're choosing what to publish. They're choosing how their data is being discovered by AI. And then when it comes to the actual model itself, large language models are constantly evolving, getting better, which is expected. But the idea is that because all of the geoinformatics is captured in these RAGs, that transcends models. So currently, only commercial models on the spatial knowledge graph side are powerful enough to actually do this. We've tried a number of the freer models. They're not there, but they're not there yet. At some point, they will be. So the idea is that you're not necessarily locked in fully to a commercial vendor or even to a single model, because the intelligence is really modeled here in these RAGs that you're creating, whether it's spatial knowledge graphs or DGGS. And then you're just using the model as a natural language processing interface. So, and the reason why again, we're doing this work with the OGC, is that in order to make these things interoperable, this has to also work in a federated context. So there's some overlapping concept here with the Army Corps example, but this is our vision for the industry moving forward. Again, because I have a lot of passion for social impact, uh, especially in public health, because that's how we got started. So here on the left, this is the reason why we need to be federated, because the monolithic approach, the commercial vendor coming in and doing everything themselves, or even just the central IT team of your government agencies, like, we're going to build the graph ourselves, and we're going to import the data from the other agencies that we need in order to answer the questions that we need to have answered. That can become currently it's a maintenance nightmare, because if I've imported data from BLM or from US Census, next year, potentially even in a shorter period of time than that data has changed, and it can be very computationally intensive to build these graphs. And one of the punchlines of the workshop when it comes to spatial knowledge graphs is we go from tabular data structures to building these knowledge graphs. And then we take that graph and we put it into a free graph visualizer on the web. And the graphs that we build in the workshop are understandably small, but even these small graphs, when you actually try to visualize them, it's a mess. It's just way too complicated. So what's needed is a federated approach where third parties can just automatically find the data that they need that's been published in graph form. They're able to pull and integrate them automatically, so that they have access to what they're lacking, and that is the geoinformatics knowledge in order to power their AI solution. And so the same concept with DGGS is interoperability up front, so that we eliminate the need for all these point-to-point integrations. Whenever someone does an integration themselves, that is something that is usable by the broader community. And then, because we do work in the UAV sensor output space, wouldn't it be great if we could integrate stack catalogs into this as well? So in other words, my company is not building the solution on the right. You guys are building your own solution that's targeted, specific to your domain. You are building the wildfire response app, but we're focusing on the plumbing, so we can actually get that information in a format that can be used by the model. So I have a little bit more about the design, and then I can get into the demos, but does anyone have questions?
I have one very detailed question, or a specific question about on your early map of several different DGS types. You had like a number. It was a refinement ratio. What does that mean exactly?
I don't know. I'll have to punt to one of my team members.
Oh,
It's
I don't know.
sorry.
it,
No
it
problem.
is the level of the resolution of the cells.
Oh, okay. Right. The zone level.
Gotcha.
Sorry, I clapped, but I was meaning to raise my hand. Are you familiar with Nowhere Graph and what's
Yes.
done with that? And they use the Google S2 geometry, and they went into explanations of why they used that. Why did you choose? And it looks like you're using the Uber hexagons. I forget the acronym. Why did you choose your grid system opposed to something like S3 geometry?
So yeah, for this is actually a screenshot of the demo I'm going to give here in a bit. But I think we're using ICEA 7, which is pretty common. We did not use H3 because it's not an official OGC DGGS. It's DGGS in concept, but it's not an official standard. That's the only reason why, not that you can't use H3.
Okay.
And And I am familiar with Nowhere Graph. I know the folks over there. I think they're great, but it is an example of the monolith graph. They have built this wonderful graph, but not every department or organization has the resources to build the graph that they need. And no one organization can build a graph that meets everyone's needs. So our vision is that the future is going to be bespoke graphs for your domain, but you're able to integrate data from third parties and keep it maintained. So the idea is that as these dependencies evolve, that you know it's changed, and you can then import those changes in a controlled manner. Think of it like as a source code repository. So there's been a new update that's been published, and I'm going to pull those changes into my graph. But there needs to be a standard for doing that. So we've developed an approach. It's not entirely federated, but it is deployed with Army Corps and in other contexts. But before we're designing the fully federated version, but we want to do that in the public, in the open with OGC.
Thank you.
Hi, Nathan. Thank you for the presentation. Really, really interesting talk. And thanks, James, for bringing up Novagraph, because I was one of the primary developers of Novagraph, so very familiar with this whole process that you talked about. A lot of this work that you did here, we did this, the entire workflow, we did this a few years ago. So just a couple. Maybe I just want to point out that Novagraph is it is a graph. I wouldn't consider it a monolith graph, because it was built to be an open knowledge graph that could be reused down the lines, and which did happen in the follow-up Proto-OKN system, where Novagraph is being used as a source for a lot of federal data sets by SALGraph, which is doing contaminant analysis, and Urban Flooding Open Knowledge Graph, which is doing flood analysis. And now I'm part of a team where we are trying to bring a ton of graphs together, one being GeoConnects, creating mappings between GeoConnects and all of the OKN and Proto-OKN graphs that were built in that ecosystem. And it's all through federation. So I would not consider Novagraph to be like a monolith graph that cannot be interacted with through federation. So that was just one point. But I guess the second thing is a question. You did talk about quantization on the DGGS, and I did have a paper about that entire workflow of quantization of vector data and raster data in the S2 grid as a part of the Novagraph work that we did. So I'm just curious to know, in your organization, like, what's the process like for creating these connections between quantized DGGS cells and data that is in graph format? Like, how are you storing it?
No, that's an excellent question. So there are a couple of approaches. So for the pilot that we did with the OGC, we did simple geometry arithmetic. So basically, if you ask a question that returns a collection, you want to understand how that overlaps with the spatial knowledge graph. We just do geometry arithmetic to find out which geo objects are within those zones. And then once we've identified that set, then we then generate a graph query to then understand that downstream impact. That doesn't scale very well. So the design that we've come up with, although it hasn't been deployed yet, is that we are, for lack of a better term, indexing the graph by creating nodes in the graph that represent these DGS zones, but only those that we're not creating zones for every single. We're not creating nodes for every single zone for a DGRS, but rather on graph import, on graph creation, or at the indexing phase. If there is a geo object that geographically resides within a zone, then we create a spatial relationship there. So that's proven to be a much faster way to bridge the jump between the zones and the corresponding geo objects that reside within those zones.
Fair enough.
And then to follow up on what we mean by federation, what we mean by federation is someone's able to publish a geo-ontology, like an individual organization can publish a geo-ontology. Ontology. It could be hydrography, and the geo-ontology is, so it functions like as a schema, so describing what's in the graph, what are the types, what are the edge types, and then independent people can then create their own graphs relative to that schema, and then they can merge between themselves. So there isn't necessarily essential, there's an essential organization that has to manage that. So if 3 organizations publish their graphs according to the same schema, then a 4th organization can integrate 2 or maybe all 3. So the idea is we're separating schema as its own first-class object that also evolves over time. Because even if you look at if you're trying to model an administrative hierarchy as a geo-ontology, administrative hierarchies are changing over time. So we're very much capturing the temporal component as well.
Thanks. I think that was helpful. But I think maybe I will also like highlight a couple of teams which are doing similar sorts of work, just if it's of interest to you or anyone else. There's the Frame team out of Renzi Institute, who is trying to like create this sort of automated mappings between schemas so graphs can talk to each other and anyone can, like access any graph and be able to like query it. And the other team being the Center for Geospatial Solutions. They are trying to like build this framework called SAL, Semantic Accessibility Layers, where you can, I think their goal more is like creating portable data products, which are knowledge graphs that anyone can build and install, so you don't rely on an organization to have their, let's say, knowledge graph service up and running for it to be accessible through federation. So yeah, I think off the top of my head, these two come up just if folks are interested, right? I just wanted to like throw out those two teams, just very similar overlapping work that they're working on as well. But
and so
very
what was the first organization, or maybe you could post it in the chat?
They are Renzi, and they are working on building Fabric, which is I'll put it in the chat. It's like it's long, and I will follow up with you as well because I just love this work. So
no, I'm looking forward to it because your brain is in this domain. We got some interesting conversations. Okay, so before we get into the demo, I'm just gonna highlight on a couple of different points. So we have some software. It's called GeoPrism, and it's a recognized digital public good by the Digital Public Goods Alliance. It's an organization funded by the UN because we've used it in the public health context, but it is a toolkit for basically helping to create interoperable graphs. Again, like it's not fully federated just yet, but the idea is that you start with a geo-ontology definition as you're importing data. It ensures that it's adhering to the that definition. But more importantly, hopefully I can cover this real quick. What makes it unique is we have this notion called a graph repository. What's keeping track of all of the temporal dependencies. So T represents time. So here we have a hierarchy, and we have GeoObject 6 that has a relationship with GeoObject 3 from time T0 to T1, but at time T2, GeoObjects 2 and 3, they merge. They become one. And so then at time from T2 to T3, GeoObject 6 has a new parent. So it's that temporal governance is what we're focusing on, because that's incredibly important from a federated context. And we're exploring how we can extend that into just taxonomies and ontologies, because terms also change, right? So, and the idea is that every reference to a location, every reference to a term is traceable. Its provenance is traceable. So when you have a field in your data set that says grassland, what does that mean? Where did that come from? Is that the same term that I'm using? So that's the idea. So it's all in the context of how do we reduce the cognitive burden on the model. So with that, thought we could jump into a quick demo. And feel free to ask questions as I'm switching my screen here. There we go. Okay, can you guys see my screen?
Yeah.
Okay, so this is really simple, but I think it conveys the point. So, all right, so I'm going to ask. So let me describe what we're looking here. So, oh, okay, maybe it logged me out. All right. This is called the GeoAI Kaleidoscope. It's an open source reference implementation for how one can build these types of solutions where you have large language model interface, and then you want visibility into the different RAG structures. And so this was one of our deliverables for the OGC AI DGGS pilot. So here we've registered different collections with the solution. And so now I'm going to ask, what collection names do we have for flood data? Okay, so now I'm going to ask the question, show me Red River levels near flood levels near Winnipeg above 5 meters. So what it's doing is actually taking the natural language question and converting it into it's called an OCL query, and then calling the collection. So in this case, I asked for Winnipeg, and it says, well, I'm aware of 2 places called Winnipeg. What are you referring to here? So I'm disambiguating. So one of the challenges of using LLMs and DGGS is when you get the result of a DGGS query, it's just a bunch of numbers. It's an array with a bunch of numbers. And the other challenging part is, so if you're writing a natural language question that refers to an area of interest like Winnipeg, that collection doesn't necessarily have any reference to where Winnipeg is. It doesn't necessarily have knowledge of how these zones overlap features. And so we're actually using the spatial knowledge graph to help determine that area of interest. So using tools, we're basically trying to find out, okay, what is the area of interest? And that's on the graph. And then once we get the geometry of the area of interest, we're using that geometry to then limit the scope of the DGGS query. Because in the engineering report, I should have included a link to that. If you stay on after this demo, I'll try to get a link to that here and post in the chat. That was one of the challenging pieces. It's very easy to write a query that will return a lot of information. So, okay. So, but wouldn't it be great if we could understand downstream impacts? Now, due to a lack of available data, we were trying to figure out how to show the interaction between the DGGS and spatial knowledge graphs. So I just asked a question about elevation. So let's pretend elevation is flood levels, right? Now I'm going to ask it, what is that corresponding infrastructure? Is there any power infrastructure that would be affected in this area? Okay, so we have some power infrastructure. And now I'm going to ask, okay, well then, what are the corresponding dissemination areas? That's like a census tract in Canada. So now what it's doing is so now we've identified the geo objects that are in these zones. Now it's generating a geosparkle query to find what areas might be impacted. So again, we're pretending this elevation data is flooding data. And so you can see that if this were that were a flood, based on this power infrastructure, you'd have populated areas outside of the flooded area, and that would be impacted in this case. Any questions there before I jump onto a different use case? Okay.
I have a question. Sorry, I have a question. This is Dave Jones. I was just wondering, as you're querying this data, what if, one of those transmission towers has a backup generator and can, power, let's say these were cell towers, and a cell tower went out, but a couple of them have backup generators and would kick on and continue to operate. Is that information that would have to be placed in the metadata for that particular tower? Or is there another way to provide supplemental information?
Yeah, no, that's an excellent question. Maybe I'll answer it this way. So one reason why the provenance and the federated architecture is so important, because in a disaster response context, things are changing. And so how do we keep that data up to date in a format that could be leveraged by the solution? And so in a spatial knowledge graph, you can allow for the creation of other nodes and other edge types that point to, let's say, point to the power infrastructure. So the idea is that if I need to associate additional kinds of information that represent the boots on the ground reality, I can create that information, and then based on the provenance metadata, I know, okay, some of this, which data was just been reported by boots on the ground and which have come from associated sources. So to your question, if one of these like substations has some sort of backup infrastructure, I would think you would want to have that as part of the metadata. This is just, but unless you have that more boots on the ground real time feed, it wouldn't know. Okay, yes, there is flooding here. Yes, here's the power infrastructure, but is it really out of commission? Is it really down and out?
Yeah, yeah. Like if the water was, say it was a foot of water around that electrical substation, but it's elevated by 2 feet. So it wouldn't,
Yeah.
Which water would be under it, but it not necessarily impacting the distribution of power.
Well, right, and if that were metadata on the actual power infrastructure itself, then you could then compare. Okay, what is the inundation level? Oh, it's 6 feet. Okay, in that case, yeah, we do think it's probably out at that point.
Right. Okay, cool. Great. Thank you.
So what I have here is like the next version of our AI, the geokaleidoscope interface. And so one of the points of feedback we got, especially from Army Corps, they said this chatbot window is it's too small because they want to be able to do things like for site selection, right? They want to be able to ask pretty extensive questions and we're getting extensive answers, and the real estate was just too small. And so the reason why I switch over to this other instance is because I'll keep this short in the interest of time, but here we see a question about this doesn't involve DGGS. It's purely flood inundation using knowledge graphs, and so there are questions that are being asked and answered. And then so for this question in particular, what is the student population that would be impacted under this scenario? I get an answer, and then I want to say view on the map. So this is a way to actually audit the answer that's provided by the model. Okay, I think I need to log in again. So yep, I did. My apologies. So yeah, so another advantage of this approach is I say, hey, view this on a map. How am I able to view this on a map? Because I have access to the GeoSparkle query that was generated to answer that question. And so actually we're rerunning the exact same query, but we're now asking for the geometry information so we can actually view it on the map. And then so here we just have one data set, but if this involved multiple data sets for the answer, you could peruse all of the data sets, and then you can drill down at the individual points. And so here we're looking at a school that was involved in the answer. And so now I'm actually looking at the graph. And so now I'm able to do full graph exploration. I can always get back to my question, but this is allowing me to sort of explore the graph that is providing all the answers to the model. I just clicked on the entire inundation scenario, so it's going to be a lot. So it'll take a little while. So while we're waiting on that, any other questions?
I'm curious how much an agency's investment in DGGS in advance helps them adopt these methods. Like if they already have the spatial infrastructure kind of as a method, does that accelerate the process?
Yeah, so the state of DGGS tooling, it's still pretty new. Even commercial vendor that we've worked with on DGGS, their support is still in its infancy. So actually, we're scoping the effort of what it would take to create that infrastructure for Army Corps to implement support for DGGS, and that is, they're hosting the DGGS servers themselves. They're the ones who are doing the quantization. It's not a lot of effort, but we're still helping them understand what that would look like in their context. So unfortunately, I don't think I have an answer for you there other than just what I just shared. I'm going to use this opportunity to copy what was posted in the chat. Oh, great. Excellent. We have the DGGS report posted here. Thank you. Oh, Francis, yeah, I know you. Yeah, we've been in a number of OGC calls together. I just put two and two together. So
Also, we're just hitting time, so some people may have to leave, but I'm more than happy to stay as long as Nathan wants to stay. But I believe next month we have Dave. Do you have the announcement for next month's presentation?
Not yet, but I will soon.
well, thanks everyone. Yeah, if you want to follow up with me afterward and discuss actual wildfire scenarios that you think would be really relevant, then that would definitely be informative for us to ensure that what we develop continues to be as domain agnostic as possible, because everything is configured by metadata. Both the graph is configured by geoontology. And so the idea is if you want a different domain, to just swap out the geoontology, a different definition, and it's applicable for that as well. Oh, hi, Dirk. Didn't see you on there. Yes, let me put my oh, and yeah, I'm happy to share the slides. So here's my email. Because the last slide, which I didn't show, has a link. So if you guys want to take a screenshot, has a link to the workshop. So if you want to start playing with the knowledge graph workshop yourself, that the DGS one, like I said, we're still working on that. Should be done by next week, actually. Here we go. So in there, you'll see a PowerPoint presentation that will walk you through the knowledge graph workshop.
And just as a for context, I'm on the Phosphor-G program committee, and I think we have over 12 of the 96 presentations have some kind of interface with DGGS. So this is the methods are being deployed in a lot of interesting situations, and I think it's kind of an emerging topic that's pretty significant.
Well, if there are no more questions, thanks, guys.
Thank
Found it
you,
interesting.
Nathan. I really enjoyed it, and we should follow up soon on. I think the applications for the wildfire scenarios I see as being really significant opportunity. We're doing a lot of well, I should say I'm doing a lot of just trying to transform data sets into. I'm mostly using H3, but transforming fire model outputs and observations into H3 friendly data frames for analysis. Like I've been playing with the new NISAR soil moisture data sets, and transforming those into H3 is like kind of leading predictors of fire behavior, which I think I'm kind of using them more as like a single like object description rather than the subject object predicate triples model, so anyways, I think it's really fascinating to see where this material goes.
Yeah, happy to follow up with you on that to learn more.
Alrighty, well, thanks again, and I'll catch up with you. I'll see you in person in Sacramento.
Sounds good. All right.
Have a good afternoon. Thank you.
You too.